Hi guys, today we are going to learn about resistors in series and parallel. For series connection, this is how resistors are connected. For parallel connection, this is how resistors are connected. Now, the effective resistance R capital E subscript, it's the same as saying the total resistance. Now, the total resistance for series is the sum of the resistance of each and every resistor. But for parallel, the effective resistance, which represents the total resistance, so in this case, we can replace it by 1 out of R total. It's the total resistance for the whole circuit. So that means the formula will be 1 out of RE, the effective resistance 1 out of RE, which is equals to 1 out of R1 plus 1 out of R2 plus 1 out of R3 going onwards. Now, so as you can see, for series, we add. For parallel, we add the reciprocals. Let us dive into examples. Example 1. Calculate the effective resistance in the circuits below. A. As you can see from this circuit, the resistors are in series. So if you are supposed to calculate the effective resistance, we'll use the formula for series connection. So we'll say R effective is equals to R1 plus R2 plus R3. So we'll only go up to 3 because we have 1, 2, 3 resistors. So it'd say R effective is equals to 1 ohm plus 2 ohm plus 3 ohm. R effective is equals to, the answer is 6 ohm. It means that this whole circuit can be replaced by one resistor whose resistance is 6 ohm. That is equivalent. Example 2. As you can see from this example, the resistors are in parallel. And for parallel connection, we use the following formula. 1 out of R effective is equals to 1 out of R1 plus 1 out of R2 plus 1 out of R3. So 1 out of R effective is equals to 1 out of 1, that is the first resistor, plus 1 out of 2 ohms, that is the second resistor, plus 1 out of 3 ohms, that is the third resistor. Now, we are going to do this, to solve this one using LCM. Using LCM, 1 out of RE will be equal to, so the LCM of 1, 2, and 3 is 6. So 1 goes into 6 times, 2 goes into 6 3 times, and 3 goes into 6 twice. So when you add that up, it gives us 11 over 6. But remember, we have a reciprocal over here. So we'll do reciprocals on both sides. 1 out of RE is equals to 11 over 6. And the reciprocal of this one, RE, is equals to 6 over 11. When you key in that into the calculator, it gives you 0.5455 ohms. That is when after rounding off. And that is the answer for that question. Question C. These are two resistors connected in parallel. So this is a parallel connection. Now for formula for parallel, because you have only two resistors, we'll say 1 out of RE is equals to 1 out of R1 plus 1 out of R2. Now, we can either substitute this one, or we can further solve this equation to give us another equation. This is allowed, but another way, you just say 1 out of RE is equals to, so the LCM of R1 and R2 is R1 times R2. R1 goes into this one R2 times, and R2 goes into this one R1 times. So doing the reciprocal on both sides, RE will be equal to the product R1 times R2 divided by the sum R1 plus R2, meaning that this is also another equation that is allowed. You can also use this one. So you just say R effective for this whole circuit is 3 times 6 divided by 3 plus 6. And the answer for R effective, when you key in that into the calculator, is 2 ohms. You can also use this one. You can also use this equation, and you'll find that the answer is still 2 ohms. Let's move to the next equation. Question 2. Using a 2 ohm, 3 ohm, and 6 ohm resistor, draw a circuit diagram using the 3 resistors of A, minimum effective resistance, B, maximum effective resistance. If you want to produce a minimum effective resistance, connect resistors in parallel. If you want to produce a maximum effective resistance, connect the resistors in series. So we are going to connect the 3 resistors in parallel, and this is what we'll have. This one will give us a minimum effective resistance of RE is equals to 1 ohm. You'll use the formula for resistors in parallel, but this one will give us an RE of 11 ohms. As you can see clearly that 11 is greater than 1, and therefore series always gives us maximum and parallel always gives us minimum. Thank you for your time. Hit the subscribe button and spread the word. Have a great day.